Network communication protocols. The Internet uses standard protocols to link several billion devices worldwide, allowing the transfer of data between destinations. The most common protocols are TCPs and IPs. A TCP is the Transmission Control Protocol. It essentially establishes the connection between two hosts, sorts packages, and transmits data between users. IP is the Internet Protocol. It is essentially the Internet's addressing systems. You could think of the IP as a unique address for information to be delivered to and from. And the TCP is what controls how the data is sorted and delivered back and forth. Another way to think about TCPs and IPs is related to standard mail and delivery services. If the IPs can be considered the addresses of the locations, such as a house, the post office, and another house. You could also have business buildings, etc. And the TCPs are the mail or delivery services, the trucks that go from the post office to the house and from the house to the post office, and back and forth. So they are actually the things that transport the letters, mail, packages from one address to another. The Internet Protocol address, or IP address, is a numerical label assigned to every device connected to a computer network. The first major version of IP was actually Internet Protocol version 4, or IPv4 for short, which defines an IP address as a 32-bit number. This was used in the first production of ARPANET in 1983. However, at this size, there is only room for a finite number of addresses, about 4.3 billion. Now, 4.3 billion is definitely a lot of addresses, but the growth of the Internet in the 1990s and early 2000s created a depletion of available IP addresses. In fact, it was considered to be a crisis at the time because no available IP address meant that no business, educational institution, etc., would be able to create any more new web pages on the World Wide Web, www. Today, we understand that no such thing happened because new information is being made available almost hourly on the Internet. But how were more IP addresses created? As more addresses were needed, the IP address needed to be bigger in size. Therefore, a 32-bit number became a 128-bit number called Internet Protocol version 6, or IPv6 for short. It was created and has been deployed since the mid-2000s. Now, what's the difference between IP version 4 and IP version 6? Well, the IP4 addresses use a 32-bit dotted decimal notation, which gives 2 to the 32nd possible addresses, which is equaling 4,294,967,296 hosts, which is approximately equal to 4.3 billion, as we had talked about on a previous slide. And here is a sample IP version 4 address, and it's also given in dotted decimal notation. So here's the original 1-byte code for this first number, which is equivalent to 172 in decimal, and then there's the dot, and then this 8-bit value, which is equivalent to 16, dot this 8-bit, which is equivalent to 254, and this last one, which is equivalent to 1. Notice in this example that there are 4 parts, 1, 2, 3, 4, separated by decimals, and each has a capacity of holding an 8-bit number. Now, the newer IP version 6 addresses use 128 bits in hexadecimal notation. This allows for 2 to the 128th power possible addresses, which is about 3.403 times 10 to the 38th power hosts. That's a lot more than where we were at with the IP version 4. So the IP version 6 addresses, they contain 8 parts, 1, 2, 3, 4, 5, 6, 7, 8. And in this example, Each part is separated by a colon instead of by the dots that we saw in IP version 4, and each of them has the capacity of holding a 16-bit number. It's also possible to find the IP address that you're using right now. Every device, such as a laptop, smartphone, tablet, etc., is assigned an IP address when it connects to the internet by the service provider. And you can look up your IP address by visiting www.whatip.com, and you can check out the website to find out if your laptop and or your phone or tablet, whatever, how they're connected. Are the addresses going to be the same? Why or why not? Take a moment to pause this video and think about those questions, and when you're done, unpause it. So when checking out the IP address for your device, you should find that the IP addresses for, say, your computer and smartphone are going to be different. They could start with the same coding, but then eventually by the third or fourth set of characters, it's going to be different. And that's again because every device is assigned an IP address that is individual to itself. So each computer or device that's connected to the internet will have a different IP address. Now let's extend what we've learned about IP addresses to domain name systems. Let's say you want to visit the website Facebook. When you open your web browser, what would you type in? Right, the IP address for Facebook, but what is that? Clearly that's not common knowledge. The IP address for Facebook is 185.60.216.35. Type the IP address into a web address bar of your browser and see what comes up. Did Facebook come up? Well, it should have, and that's because 185.60.216.35 is the IP address of Facebook. However, that address is not common knowledge. Trying to remember all of those numbers is very ineffective and inefficient, and that's why the domain name system was created. The domain name system, or DNS for short, is a naming system for services and resources connected to the internet. It translates various names called domain names into IP addresses that designate the specific location of that resource on the internet. Think of it as a phone book that connects names to numbers. The domain name system allows users to find information without looking up or memorizing the IP addresses for these websites. An internet domain name is organized into a hierarchy. For example, each part of the domain name for Facebook has a specific meaning. The first part, HTTP:// is the communication protocol. The www is the subdomain. The second level, or domain name, is Facebook, and then the top domain level is .com. And both the second level and the top level in the domain name are the root domain. The diagrams on the next few slides show the hierarchy of each section in a domain name. The first part is the root domain. The root domain is where all domain names are stored, and it's denoted by a dot. Next, we have the top-level domains. So after that last dot, you have either a .com, an .org, an .edu, sometimes it's .net, and these top-level domains are the second largest groups of domain names. And below the top-level domains are the second-level domains, or SLD as the acronym, and they are the main part of the domain name that is recognized, and it usually specifies the organization or business. So you could have google.com, facebook.com, NJCTL.org, wikipedia.com, etc. And below the second-level domains, we have the subdomains, such as www, or mail, or drive. The subdomains are domain groups smaller than the second-level domains. The www is actually a smaller domain group under each second-level domain. Let's look at an example to better explain this. A fully qualified domain name, or FQDN for short, specifies its exact location in the hierarchy. So the fully qualified domain name www.facebook.com travels this path down the hierarchy. So you have the .com and then Facebook and www. So that's the fully qualified domain name. Domain names are vital because they are linked to specific IP addresses through the domain name system. The domain name system has a network of servers that maintain routing tables that associate domain names with IP addresses, such as the one shown below. So the domain name for mit.edu links to their IP address 23.79.156.252. And here are a few more.